So in this video, I'm going to go through the collision system for the game. So I'll go through the collidable base.h first. Um, Once again, it's very similar to the other bubbles. The only difference here is it's just a .h because of all these type names. Very difficult to work with, but I got through it. As you can see, it's still a command pattern. So we submit the command for deregistration, registration. Yeah, we only have one of them per registration or per collidable. And then we'll look at that right. That's the alarm right here. So we have only .h's for these two because of the type names. So we collide, we register, we register the command, or we create the registration command, we register it with the scene. Yeah. Yeah. So same for the deregistration, the execute, deregister with the collidable command or manager. So that's the base collidable. So now let's look at the collider group base. So once again, deregister collider collection dot remove. So these are the groups like B-sphere, such. Collider collection. So we get the collider collection of all the they're not B-sphere game objects. All the game objects of that kind. And yeah, it's a singleton, obviously. Instance collection of the colliders of the type C. So now collision volumes, that's B-sphere. Here we go. We finally see some .cpps emerging. Here is the constructor for the B-sphere. Center is obviously just getting the center of the model, getting the radius of the model. Default constructor should never be called, but I think it is for creating them at first, and then they're filled in. Calculates data for the collider. We'll see that in a second. Calculates the intersection. Intersection of B-sphere, intersection of volume. So there's a difference. Gets the center, returns the center. Gets the radius, returns the radius. Center, radius. Okay, compute data. So this is basically computing where it is and where it should be, what it should look like. It's pretty simple. Yeah, and it works. And we see that through the visualizer. Intersection. It uses math tools, which I will pull up here. So math tools. Ta-da! Math tools uses has a few methods. We got the intersect here between two B-spheres, intersect between two collision volumes. And this really shouldn't be called, but it's just there to catch the other ones. As we can see, it always returns false. And it calculates the distance between two vectors. I use this in the house for when the player was close enough to shoot at. So here we see calculating the intersection of the two spheres. Intersection of the two collision volumes, once again, should not be doing this test, so return false. and return the distance in between the two. So now let's get back to collision volumes. Once again, just calls on the intersect. Get center, returns the center. Get radius, returns the radius. So now let's look at the collision volume base. Once again, it's exactly like the collision volume B-sphere. It just has the exact same methods. Intersect, intersect, compute data. It doesn't have any of the storage, obviously, as the other things. So now we'll look at the collision commands. So let's look at the base one first. We have obviously execute and default constructor and destroy. The base should never be used, but it's pulled in by the self and pair. So let's look at the pair first. So this is called to test if these two collections are colliding. And so it goes through the list. If two are intersecting by the math tools, calls the collision on both of them for eaches on each other. And then the creation of the command right here. This is done. These are made in the scene. So right here, boom. Yeah. Well, it's done through the scene object, but it's through the scene.age. But this is where the user calls it, and it gets the methods through right there. So there you go. So that's the pair. Now let's look at the self. So obviously, it's not going to need to do as complicated of a thing with self. So what it does is it tests. Well, basically, it just makes sure it loops through once. It only loops through once, and makes sure that it's not going to be testing the same things against each other twice. So this is incrementing by one, and then this is the one after that, and just test the rest of the list, because the ones previous to this one have already been tested. Now obviously creating the collision self-test command. Okay, so now let's look at the collision manager, and then we'll look at the visualizer in a second. So the collision manager, obviously scene's a friend class, process collision tests, that's called in the update in the scene, default constructor, set collision self, and then set collision pair. Yeah, for the scenes. Okay, let's go to the .cpp. Process collision tests. Obviously, we just look at the list of the collision tests, and which are stored somewhere in here. Let's just pick out collision tests. It's right at the top. That's why I missed it. So collision tests list, because we don't really need to order anything or figure out a very specific one. So we just have a whole list. We run through the whole list. We execute all the commands in the list. And then to destroy, we just destroy all the commands. So now let's look at the visualizer. And the visualizer is here, obviously. So right now we only use the sphere. We only have the bounding sphere. So I only have the unit of sphere for the visualizer. This is a singleton, obviously. It's only one instance. It has a default color, but we never use that default color because of how we use the visualizer to test whether or not things are colliding. Here's the unit sphere that creates. Render bsphere and render all are both private. So, yeah, here we have the bsphere and the the collision volume here, and then the position right here, stored in a pair, a list of pairs that are the bspheres that we are going to be showing. Now, if called wherever, we can call this wherever, show bsphere with a collision volume and a color. We put it into the bspheres list. We can place it at the back, and then when render all is called in the draw manager, it will render the bsphere with private bsphere, with private render bsphere, which actually sets, it only has one unit bsphere, so it just sets the world, sets the color, and then it renders. And then at the end of the render all, it clears. Because you might only want them drawing with certain frames. Now we can see the colors, colors.h. So this is basically just so that we don't have to define the colors all the time. We can just use green or red or blue or black or white or light gray or dark gray. It is a singleton and can be accessed wherever wherever a visualizer can be. Yeah. So that is the collision system. We saw it working earlier in the demo. We've seen the visualizer working before too. Yeah. So I think I'm going to end the collision system video here, and then go into the alarms next.